Hello everybody, we are group number 1 in the tutorial 004. We are now presenting our focus study in BLE 470. Our topic is augmented reality and virtual reality in construction. This is our content page. First, we are going to introduce the technology of AR and VR. Next, we are going to show some application of AR and VR in the construction discipline. Also, we are going to show the case studies of both technologies in construction. And finally, we are going to analyze the challenges in AR and VR. We will also provide suggestions and conclusions for this topic.
Virtual reality is a technology that can simulate an immersive environment that users can experience unique insights into the way the real world works. VR represents the effort to create a virtual environment through visual and immersive assistance so that users can feel the real perception. However, due to the lack of sensory feedback to adapt to perceived and cognitive perspectives, it can only provide a limited level of realism. With wearable VR devices like Oculus Rift or Google Glass, VR can replace the user's perception of the world around it with a computer-generated artificial 3D environment, and it's not necessary to build such a virtual 3D environment based on a real environment.
Starting to the background information of AR, with regard to PAN in 2010, AR is the medium mixing the information into the physical world by taking the advantage of the decreasing cost of computer and the huge improvement of computer simulation ability. AR is nowadays be developed and adopted. In these pages, we will go through the working principle of AR by inputting the data of surrounding environment and the virtual data into the computer, and overlaying this information, the mixed environment will be created. The user can view all the viewpoints of the simulated project, and one of the famous examples in Hong Kong is the mobile apps of IKEA in Hong Kong. It's now applying AR into the apps for the user to decide if the project is suitable for their office or home before they purchase it.
In this part, the application of VR and AR technology in construction industry will be covered. First of all, for the AR technology, the idea of AR technology in construction industry is to provide a more accurate view of what will be built, including all layers of material and installations that are often complex to understand through drawings. For this, the 3D plans and even virtual model holograms are used to improve the understanding of the project and to facilitate the execution of the project. Besides, AR technology also gives a better presentation of the site area. It helps the designer for a more accurate design and planning for the building. Moreover, besides from the presentation of the building, AR technology can also be used for equipment monitoring. Every construction site has tons of equipment and there may be hundreds of different moving machines. AR technology can help the workers to recognize where those machines are and want to utilize them at a particular moment. For the VR technology, it also helps a lot in the new generation construction industry. VR uses the computer simulation software to transform 3D models of BIM programs into a realistic environment that workers and customers can interact with it. Hence, the construction companies that use VR are able to eliminate the potential rework issues. When it comes to large and complex construction projects, VR can help workers collect the input from a number of different parties, and many VR tools let the users showcase their design to more than one person at a time, allowing for real-time feedback from a predetermined group of people, and some even allowed up to 32 users at the same time. Large construction companies, and including their workforce, in walkthrough demonstrations and ask for their feedback as part of the constructability process. Besides, VR technology can be installed in a safety head, which forms a smart hard head. Smart hard heads combine a traditional hard head with a smart glass and virtual reality technology to allow users to train their employees by simulating hazard conditions. Workers could also use them to practice operating and maintaining equipment without the safety concerns or implications of doing these tasks in real life. In the case study of AR technology in construction industry, HoloLens will be covered. Microsoft HoloLens is the main device used by Windows Holographic. HoloLens is a smart glasses product for Windows 10. It uses advanced sensor and a high-resolution 3D optical head-mount full-angle lens display and surround sound. It allows the user to interface and to communicate with the user in augmented reality through eyes, voice, and gestures. HoloLens was announced by Microsoft on January 21st of 2015. Companies such as Gilman Building Company used this equipment in their construction work. According to the news report, when Gilman employees looked at a sample of construction case while wearing HoloLens, they found that the steel beam used to support the building walls were too long, and it is different from the original company design. Fortunately, it was discovered, and so that the supplier could be notified and to saw the steel beam short as early as possible, without delay, to let the worker adjust the position of the track supporting the steel beam. And this discovery saved the company around 5,000 in labor costs. In the future, relying on AR and holographic images can be superimposed on the user's environment and allow the industry with an output value of up to 10 trillion US dollars to further improve the efficiency and reduce the possibility of overspending, waste of building materials, and prolong the construction period.
In Hong Kong construction industry, we have found two examples that VR is applied. The first one is Cave. So Cave is a technology that tracks motions of users' head and the movement of their control stick. It is usually operated in a cube-like space to create three-dimensional virtual experience, such that the area and the space provides immersive virtual environment for the users. Through the initiation of the EMSD and its platform ENM InnoPortal, a collaboration has started in the integration of Cave into BIM model simulation system. It provides the construction industry to have an interactive approach for reviewing building models, which can enhance their construction management skills, and also the interactive training in construction safety, which can enhance the skills and the awareness of construction workers. The second VR technology that we found applied in Hong Kong is hologram. Hologram is a physical visualization technology that is produced by the means of light diffraction. In this technology, various textures can be shown through the images, and it is for the use of comprehensive visual experience in different professions. And hence, this can be applied in the construction discipline. It also has a main point that it supports for collaborative images design, which is important for the architectural purpose. And this time, hologram technology is used in the EMSD Interactive Training Center. In the center, the holographic tutorials are provided for lift maintenance and welding training. So this provided the construction workers an advanced off-site teaching experience that with particular procedures and details. Besides, an integration of BIM asset management is used with the holographic display, and it is to demonstrate the Hong Kong's Children's Hospital project.
Despite there a huge amount of advantage can be taken from applying AR and VR in different fields, according to Martin in 2019, there are still four main barriers of those applications. The first one is the cost of adoption. The second one is the control issue, then the device limitation, and the mobile and connectivity become the last barrier. And I will go through it one by one detail in the following. First of all, there are two main issues on the cost of adoption. The first one is the AR and VR is relatively new and advanced technology. It will cost up to 2,000 US dollars for one single device. Therefore, the owner may not be willing to invest such amount of money into the one single device. And moreover, there is hard to find a direct way to make profit in the VR and AR application. Then move on to the control issue. During using AR or VR, several devices are need to control, and huge amount of information will be received in the same time. It will cause the user to feel confused while using this system. Therefore, the training cost may need to provide to the user, and it will cost the extra expenditure, which will also reduce the willingness of the owner to apply AR and VR in different fields. And for the device limitations, size and weight are the main consideration here. To improve the FOV to the expected value, the weight and size must be increased, which will cause the uncomfortable for the user. Therefore, in Ransom technology, the FOV cannot be achieved the expectation of the user. And move on to the mobile connectivity. 4G LTE is the faster speed we can use right now, which may cause the latency when we are using AR and VR. It will also become one of the barriers of applying it in different fields.
By improving the capability and ease of use of the technology, an acceleration in field and office use will be faster. From the technical perspective, AR's interfacing ability with BIMs also be enhanced to be very precise, as AR elements won't line up with physical ones without high accuracy. Solving this problem can greatly increase its availability in construction. From the safety perspective, AR's technologies like HoloLens can be distracting. Therefore, it should be carefully designed to ensure that it integrates seamlessly with the real environment in the safest and least disruptive way in order to prevent serious injury or death on an active construction site caused by small disturbances. The government should also increase the research and development resources on AR and VR technologies in order to lower the entry cost of this technology.
And this is the end of our presentation. Thank you.